Hello everyone, I really appreciate you coming to watch and listen to me talk about event sourcing. Today I realize it's the last talk before the closing keynote, so I appreciate it. In case you haven't noticed, I've got a bit of an accent. I'm originally from Sweden. I've lived here in the States for a few years, but for the last 7 years I have made my home in Australia. So I've flown all the way from Australia to come here to talk to you about this. I work for a company called Envato. Chances are you have never heard of Envato. What we do is we build large-scale online marketplaces where people can buy and sell digital goods. We got all of these ones. You may have heard of Theme Forest. It's consistently ranked in the top 300 of the world's largest websites. It's been as high as about 70, but it fluctuates a bit whenever Alexa changes their algorithms. So we're not super massive scale, but we're still pretty large. But we're not here to talk about that today. We're here to talk about event sourcing. Event sourcing is a pattern that we have had a lot of success with at Envato, and I wanted to share some of the things that we've done and hope that it can be a benefit to you. We're also going to make an extra appearance of CQRS architecture. Actually, before I go into that, how many people have heard of event sourcing before? Right, and how many of you have actually used it? Only a couple. Excellent. Good. What about CQRS? How many people have heard about CQRS? Some fewer. And how many of you have used it? A couple. Cool. So we'll talk a little bit more about that. Let's start about what event sourcing is, since many of you haven't heard of it before. To do that, we really need to talk about what an event is, right? Event is one of the most overloaded terms, I think, in our industry right now. In this context, when I talk about events, I'm talking about a business fact, something that has happened at a particular point in time. A business fact that has happened at a particular point in time, something that is absolutely core to my domain, so that if I lose it, it will cause problems. I'm not talking about click streams or anything like that, where if I lose 0.1% of them, it doesn't really matter. I'm talking about really, really crucial core events that have happened. So if we take let's say a calendar domain, this is a domain that hopefully you are all familiar with. We would see, in an event-sourced world, we would see events like appointments scheduled, rescheduled. We've moved the location of it, it's been canceled, we've extended an invitation to someone, we've sent notifications and accepted and declined invitations. These are the kind of events that we're talking about. In my domain, where I come from, where we have basically an e-commerce site, we have items. These are the products that are being sold. They can be submitted and approved, they can be added and removed from shopping carts. They can be purchased, we can have withdrawals, and so on and so forth. These are the type of events that we have to deal with. So event sourcing in this context, now that we've defined what an event is, actually, before I go on to event sourcing, let's talk about what it's not. Standard practice for many of us is to store the current state of an object. If you use object-oriented programming, the standard practice is to store the current state of this object in a database using an ORM of some sort. So when the state changes of that object, the database representation also changes. So let me give you a concrete example. John's gotten married, he wants to take his partner's last name. In an ORM, we'd have a user object, and that user object would be represented in a database like this. And then when we update that user, the database representation changes. So it goes from John Reed to John Hill. In event sourcing, we don't do that at all. In event sourcing, what we do is we take all of these events and we create an append-only set of immutable events and use that as the source of truth for our application. And then we derive basically everything else from these events. So basically, we can source event sourcing, right? We source the current state of our objects using the events. So in an event source system, we would have a sign-up event of some sort when a user first comes on board. We say, yep, John signed up. Here's his first and last name because he gave that to us at the time of sign up. We can then, by replaying that single event, we can reconstitute the current state of that user. And then when we change the name, we just generate a second event called change name with the new last name. And then, in order to get the current state of this user again, we just take the first event and add the second event on top of it, replaying them in this order to get what the current name of that user is. This makes everything else completely disposable. So once we have these events and we're actually capturing all of the changes that have happened, we can do whatever we want. We can create different models, we can create different views, and we'll talk a little bit more about that later. And then it also means that we don't actually need to store current state anyway. We can always derive it, we can always get it back, we never need to store it. This is a pattern that's language agnostic, by the way. It doesn't really matter what technology you use. You can do this in functional programming. I know I'm talking about objects here, but you can even do this in functional programming without any problem. So what is it about event sourcing that's good? What is it about it that I like it? Well, I've been on a bit of a journey in my career, and I've come to the conclusion that delete is evil. I think that data is basically the core of what we do as software developers and software engineers and software architects. The software that we have exists to collect, modify, manipulate, present data. Like without data, the software that we use or the software that we build is kind of pointless, kind of useless. And the data that we have, it survives even when the technology doesn't. I've worked for companies that have existed for hundreds of years. They still have all of their customers. They still have all of their purchases and sales and everything, and they've gone through so many different technology solutions through that time, but the data persists, the data remains. So even though they've, in the 70s and 80s and 90s, they were all using different technologies, the data still exists. So yeah, delete is evil. I don't like it. I kind of skipped ahead, but I'll preface the next slide by saying that if delete is evil, there's obviously a lot of things we can do about it. I've used soft deletion libraries and so on and so forth to kind of try to get around this problem. But then I also realized that every single time we update our data, we're actually deleting data as well. We are taking what was there before and we're replacing it with something else, which means that we are deleting the data, and so update is kind of evil too. And this kind of led me down the track of event sourcing, where you're never deleting any of the core things that have happened. You're only actually appending. You're using, instead of using delete and update queries, if you use a SQL database, you're using insert and select instead. I also like it because it puts the business concepts at the very heart of the system. So the events that we saw before, appointment scheduled and rescheduled and so on and so forth, these are the actual actions that the users are taking. They're not abstractions that we as software developers have created on top of what the users' actions are. They're not interpretations of what the users are doing. It's the actual action that they are taking. It's the actual thing that has happened. And putting them at the very heart of the system and removing these abstractions can surely only be a good thing, right? And the other thing that many people don't realize, that this is something that's tried and tested. The canonical example of an event source system is your accounting system, right? The accounting system practices that we use today have been in effect for 500 years. And you wouldn't, I think that's the next slide. We're already using event sourcing. Your bank account is event sourced. The current state of your bank account is the balance, right? But that balance is ephemeral. You can throw that away and you can recalculate it simply by replaying all the debits and the credits, all of the events that have ever happened over the history of that account. So you're using it already, and you wouldn't do it any other way. If your bank suddenly decided that they were going to start modifying transactions that have happened in the past, or that they were going to delete transactions that have happened, you would probably lose your mind and get quite angry and change banks. At least that's what I would do. And if you make a mistake, if you transfer $10 and you meant to transfer 100, you can't undo that. You can't change it. You can't go in and modify that value. You have to transfer an extra $90 to make up for it. Actually, if you're an accountant, I'm not sure if there are any accountants in this room, but if there were, they would say, no, you don't transfer the $90. You transfer the $10 back, and then you transfer the extra $100. The other thing when you're working with distributed systems, as many of us I'm sure have, is current state is really hard to distribute. Current state is really, really hard to move around. But append-only stream of events are really easy to distribute because they never change. They're immutable. And last but not least, and this is a big perk for me, you get a free time machine. Because you can understand and get the state of your system at any point in the past simply by getting the events up to that point. But it's not even about that. It's also, you can actually try to, without trying to predict future features and future requirements, you can build future feature much more easily. So an example of that was, I worked in a company a few years ago, another e-commerce company. We had a shopping cart. That shopping cart was a simple ORM-based stored with an ORM in a database. So whenever I added something to a shopping cart, there was a row in a database table that got added to it. Whenever I removed something from a shopping cart, that row was deleted, right? And then a couple of years later, after the shopping cart had been built, marketing comes in and they say, wouldn't it be great if we could send emails to all the users that have removed stuff from their shopping carts? Because chances are they might want to buy that again, right? And we go, well, sure, we can start capturing that data, and then maybe in 6 months we'll have something for you, right? In 6 months we'll have gathered enough removed items to actually be able to do any of this. With event sourcing, all we'd have to do was just go, okay, take all the items removed from shopping cart events, and off we go. So let's talk about CQRS. CQRS comes from something called CQS, which you may have heard of. CQS is short for Command Query Separation. And it states in object-oriented programming, you have methods on objects, and methods can only write or only read. If they're writes, they're called commands. If they're reads, they're called queries. They cannot do both. So a method can either mutate state or return state. It cannot both mutate and return state. CQRS, I like to say, is CQS on steroids. It's short for Command Query Responsibility Segregation, and it's basically taking that one level of abstraction up. So rather than having methods that can either mutate or return state, we have objects that can only read or write. In our world, we actually take this an extra step further because we create entire subsystems that can either read or write data. So the way that it works is basically like this. We have a client. A client can be anything. It can be another app. It can be a browser. It can be a very thin layer in between the user and the system. And any time a client wants to write something, they go to a command handler. And every single time they want to read something, they go to a query handler. And by the way, this is how we do event sourcing. That doesn't necessarily mean that it's the only way to do event sourcing, but it's something that we've been using and with some success. And both of them depend on event source, so the arrows here indicate dependencies. The arrows here is no longer dependencies, the data flow, in case you wonder why they just flipped. So if a client wants to do something, they send a command to the command handler. And the command handler then looks at that and determines whether you're allowed to do this thing or not, and if you are, it results in an event. It's important to note that when I say completely different subsystems, these have different DNS endpoints and different load balancers and all of that as well. Commands in this case represent user intent. I am intending to do something. Am I allowed to do it or not? And these commands can be rejected. So there's a set of validations rules that happen in the command handler. And if they are successful, we create events. So a command is usually declared in the imperative. So something like schedule appointment. And then if it's successful, it turns into an event called appointment scheduled. On the other side, we have a client, we have a query handler which has something called projectors. These projectors maintain projections that are basically views of data. They're materialized views of data, and then the client can query these projections for whatever information that they want. So projectors just subscribe to the entire event stream and process the events that they're interested in. The projections are completely denormalized. And there's a one-to-one relationship between projectors and projections. So you have a single projector that's responsible for updating a single projection, which is typically a denormalized view, a single database table. Can in some cases be multiple, but tends to be a single one. And then we have a single projection for every API endpoint or screen in our system. So whenever I try to query something, whenever I send a query to this API, I'm only ever querying a single table in order to get that information back. And yeah, query handlers query projections and return DTOs, simple DTOs to the client. Problem here, well, shouldn't say problem, the challenge here is that while commands and events are synchronous, or writes are completely synchronous, and reads are also synchronous, the thing that goes into the event stream and creates these materialized views are asynchronous, which leads us to eventual consistency, which is really the thing that we're not supposed to talk about, but we're doing it anyway. The thing is, the world already is eventually consistent. And this is just another way of kind of trying to model that in computers as well. And eventual consistency is really about time. So whenever I talk about eventual consistency with somebody, I say, okay, yes, whenever you write something, you might not be able to immediately read that back. That's what eventual consistency is. Is a nanosecond of that lag okay? Is that okay? And most people would say, yes, a nanosecond is fine. And I say, what about a month? It's a month of eventual consistency. If it takes a month after you write something before you can read it back, is that okay? And most people say, no, a month is too long. Well, I say, what about a week? And they say, no, a week is too long too. And I say, okay, so every single time you unsubscribe from a newsletter and it says, please allow 7 days for this change to take effect. Anyway. Well, we accept it, right? Because it happens all the time. But anyway, so if we say a nanosecond is okay and a month is not okay, that means that we have a range now, right? Somewhere in between a nanosecond and a month is our acceptable threshold for how much eventually consistency we can tolerate in our system. And risk here is always a function of time, and it's going to depend on your system. And there are lots of ways to deal with this, minimize it, and deal with it from a user perspective as well that I'm not going to go into right now, but please feel free to come talk to me about that afterwards. It's always a risk is always a function of time, and it's going to really depend on your system and what the tolerance for each system is. The next concept that I want to explain quickly is downstream event processes, which to me is the most interesting and most awesome part of this entire architecture. So DEPs, because downstream event processes is a bit of a mouthful, DEPs are also so dependent on the event store. And what they do is that they process events like a projector, and then they can emit events back or otherwise trigger behavior or also possibly trigger behavior with external services. So like projectors, they process events, but they can react to an event by emitting another event. And we'll have some examples of what that might be later. They can also react by triggering external behaviors. So this is sending emails or something like that, in which case they usually also emit an event by saying email sent. And these downstream event processes are single function, single responsibility, and encourages a very clean separation of concerns. If you want to use the microservices buzzword in this architecture, this is where you use it. These are the microservices of this architecture. So let me give you a case study from my work. Country conflicts. The business problem that we had was we needed to detect and investigate conflicting information regarding a user's physical location. Basically, if somebody says that they're in Argentina, but they withdraw money to a bank account in Switzerland, we need to know about that because of tax, right? Death and taxes. We need to deal with this. So we created a specific service called the Country Conflict Service that gathers evidence of locations from lots of different products, and then it surfaces and distributes conflicts to other products that are interested in it. So this service, it gathers all this evidence and stores it as events. And then we have a downstream event processor that looks at all this evidence. And there's a single downstream event processor that says, Argentina and Switzerland, conflict. And it races a conflict detected event. We have another downstream event processor that subscribes to the conflict detected event and says, conflict detected, I know what to do with that. I'm going to send the user an email saying, I've detected a conflict, you should probably do something about that. Then you might have another downstream event processor that looks for new evidence that the user might provide and auto-resolves conflicts. We also have an admin UI where admins can issue commands to manually resolve conflicts. So if they talk to a user and they decide that they want to manually resolve it, that's how they do it. After 30 days, we get a grace period expired event. And we have yet another downstream event processor, so we're up to 4 or 5 downstream event processors now, who checks whether this grace period expired, so we want to check, is this conflict resolved? If it is, cool, we do nothing. If it isn't, then we raise a conflict activated event. So in this domain, we get all of these different events. We've got evidence provided, detected, notification email sent, automatically resolved, manually resolved, grace period expired, and activated. These are the events. These are the core business concepts that this system is dealing with. And meanwhile, we are maintaining projections that other systems can query to say what are the activated conflicts right now, which ones have been resolved recently, and whatever views that the other clients need, we can do that. This is a well-defined, simple, small example, and I use it because it's something that I can explain in only a few minutes. But we have built systems that are significantly larger, so don't think that this pattern is something that only works for these very small domains. So why is this CQRS architecture good? Well, I think it really encourages single responsibility. The command handlers only care about one thing, which is validate the command and issue an event. The projectors only care about maintaining a single projection. The downstream event processors typically only subscribe to very few events and only have really one job. The command and query handlers, because they're completely separate subsystems, they can scale independently, which I think is super important. We're super read heavy, where we have 99-point-something% reads. So we can really scale and actually put the query subsystems in multiple data centers and make them redundant as well. Writes are fast because you're only really doing very little. You're loading a few events to determine the current state of something in order to determine whether you're allowed to do it, and then a single query. But reads are even faster because you're always querying denormalized views. And these projections, they can just be thrown away when you no longer need them. And I really think that there's a huge benefit in separating the recording of what happened from interpreting what happened. Because you can really also limit the blast radius of the changes that you make. So if you need another way of looking at data, you just create a new projection. If you need another user action, you just create another command handler for it. So you can make individual changes without affecting any other parts of the system, which in turn reduces fear and enables very rapid change. And I think this is a potential recipe to keep the cost of change lower for longer, which is really a key component for me. And the heart of a system is always more stable than the edges. So we can keep innovating, we can rapidly expand on the edges of our system, new views, new command handlers, but the core of our business, the core of our domain is going to stay relatively intact, so the events are not going to change that much. It's just how we interpret them that's going to change over time. So, to talk about, in the very end, is this a pattern that you should use? Well, maybe. I don't think this is a solution that's appropriate for every problem. There are particular domains where it suits better than others. Like I mentioned, we're very read-heavy, and this tends to be a pattern that works better for read-heavy systems in our experience. It's also well-suited for commerce-oriented domains, clearly e-commerce, et cetera, anything financial. Or anywhere where history is important. So one of the things that we used this for was our identity system. Just because a user changes their email address doesn't mean we want to throw away their old email address. Like, history is important. I've borrowed and modified the strategic design diagram where you have complexity on one axis and competitive advantage on the other to kind of determine where this might be something that fits. If a system is low in complexity and low in competitive advantage, just keep it simple, use Ruby on Rails or whatever. If the system is high in complexity but low in competitive advantage, that tends to be the kind of thing that you want to buy, right? That tends to be accounting systems or ERPs or data warehouses and so on and so forth. If it doesn't set you aside, if that's not your domain, it's not going to give you a competitive advantage, but it's still very complicated, so don't build it yourselves. If it's high competitive advantage and low complexity, what the fuck? Like, just get out of that business because somebody else is going to come and do it for you. But if it's high in complexity and high in competitive advantage, then event sourcing might be a thing that you can use. In summary, I think this is a great tool to have in your toolbox. If you haven't used it before, keep it in the back of your mind. Thank you very much. I'm not sure how much time we have for questions.
We're up against the break, so we have time for questions.
Excellent.
But before that, I would like to give this gentleman first shot because I cut him off twice already.
Yeah.
I don't have any questions.
That's just perfect.
Great job.
Thank you. Thank you. All right, questions?
Okay,
Yes?
just question. We are using also event sourcing.
Yes.
What we realized that between teams collaborating,
Yes?
when we moved the complexity or the dependency between teams was in the administration of the event semantics.
Yes.
Do you have similar observations?
Yes and no. So for us, events are internal to a system, and we don't have systems that span multiple teams. So this is really important. External systems do not see the events directly. The events are internal to the system, and we, as a client of that system, you query a projection, never the events directly. So, events are internal to a system. Yes?
So based on your description, you model the projections around your DTOs, around your UI.
Yes.
Are there situations where you model the projections around resources exposed in a RESTful API?
So the question is, I should probably repeat the question for the camera. The question is, we tend to model the projections based on screens in a UI. Are there situations where you'd want to model it resourcefully for, say, a REST API? Yes, absolutely. So, in fact, most of the systems that we have that are event-sourced are APIs, not any systems that even have UIs. So, in APIs, basically what we have is lots of endpoints, and we have individual denormalized projections for every single endpoint. So, is it resourceful? Yes, to the client of the API, it is, but internally it kind of isn't. I'm not sure if that makes a lot of sense.
I'm thinking if you're using Angular
Yes.
or in a composite UI,
Yes.
I wouldn't think the traditional DTO way, you would
Sure.
more like a
Sure.
break into resources.
Yeah. So if you're using Angular or something like that on the front end, yeah, that's not a use case that we've had. But I can also easily see that you could potentially build up more standardized, resourced models, view models, and just query them as needed. It's the DTO way is the way that we've gone with it, but that should also be possible. It just means that whenever you're querying, you might hit multiple view models rather than a single projection, if that makes sense. Other questions? Yes?
So you mentioned that it's really good for read performance, but
Yes.
that seems to ignore the cost of the projection.
Yes.
So you have to know all of your reads in advance, all of your the exact structure of your reads in advance.
Yes. So the question is, it's optimized for read performance, but it means that you have to understand what your reads are going to be beforehand. And yes, that's absolutely true. Yes. Yes.
For read optimized performance, you will most likely store your current state projection database. And in your example about bank account, it is very likely that database people will create a constraint that do not allow you to say negative dollar amount. In case of event sourcing, you create two events, two withdrawals, that one of them would make count on negative.
Yep.
And your downstream processing will not be able to absorb that event. How do you handle this?
So the question is, if you're not storing current state and you, for example, have a constraint that says you cannot go into negative balance on a bank account, how do you deal with that? The command handler will always load events and replay them in order to get current state, which means that it will calculate what the account balance is before it allows you, before it accepts that particular command. So the command handler, so to speak, always knows and understands current state. It loads the events, replays them in order to process a command, because it absolutely needs that current state. But we don't need to persist it in between requests, right? Yes?
So what happens when the list of events gets extremely long?
So, yeah. So this is one of the most common questions, which is, what happens if the list of events get extremely long? So the short answer to that is, you only need the events that are particular to one object in order to figure out whether you're allowed to do something on that object. So you don't need all the transactions in your system. You only need the transactions for that one bank account, right? So that's a way to keep the number of events low on a per object basis. We use domain-driven design for all of this, so we call them aggregates. So on a per aggregate basis, we keep the number of events as low as possible. Having said that, there are sometimes situations where the amount of events on a per aggregate basis balloon to the point where replaying all of them is not feasible. If that's the case, you can use snapshotting, or rather the memento pattern from the design pattern book, which is basically, you're not storing the current state. You're storing state of a particular event. So you can say every 1,000 events, we want a snapshot. So you take a snapshot. And then let's say you have 100 events after that. You just load up the snapshot, and then you just process the following 100 events, and you don't have to go all the way back to the beginning.
So neither the projections have any caching?
So the projections are, the way that the projectors work is that they have pointers to where in the entire event stream they are. So they just kind of tail the event stream. They would rarely need to go back to the beginning to do anything, but they just kind of tail.
So that's kind of a state.
Yes, but that state is also something that you can throw away. You can throw away a projection and restart the projector from the beginning, and it will just start and go. You do the same thing all over again.
Can you talk about how you maintain the order of operations? Are you using like conflict-free replicated data types? So you have two writers. Sorry, I missed this part of it. So
Yep.
But order matters. Are you using like lamp or clocks or some crazy mechanism
Right.
to keep them in order so they replay in order?
So the question is, how do you? I'm paraphrasing your question. The question is basically, how do you prevent race conditions in writing data?
Right.
Yeah, preserving right order. The answer, there's no short answer to that other than to say that there's a lot of different schools of thought on it. Our CTO, for instance, is very strict on, he believes that writes should be through a single process. I'm not sold personally on that. There's another, you can do some sort of, there are other developers at my company who are a big fan of locking. I tend to not be a big fan of locking either, but you can basically lock based on aggregate, based on a particular aggregate. Another option is sharding. So sharding writes for particular aggregates to individual servers or individual processes. So that's another way to do it. It really depends on your scale and fault tolerance and so on and so forth. But there are lots of different ways to deal with it. Yes?
On like a cold start, does that mean you have to replay all events for the views to be repopulated?
If you do a completely cold start, then yeah, on the view side, in the query side, your projectors will have to start all the way from the beginning. Yes, that happens very, very, very rarely, like if ever.
Unless they persist their cache.
They do persist they persist their pointer to where they are in the stream, and then the projections that they maintain are persistent, right? So yes, they can persist their caches, but it's not something that we're super concerned about in terms of disaster recovery and so on and so forth. We care very deeply about maintaining the integrity of the events, not so much about the integrity of the projections, because if we lose them, it's okay, we can rebuild them, it just takes time.
Any more questions? No? Thank you very much, Sebastian. Wonderful
you.
talk.